So small introduction on computational intelligence and the computation intelligence. So the intelligence which applied to all computation machine, just for adapting behavior of any bird or any other animals. So you are adapting a behavior and apply to all kind of technology, even for cloud, mobile, or haptic technology. So all the technologies which depends on computational intelligence. So each and every machines which operates based on computation intelligence. So it starts with a small intro on computation intelligence, then which applies to all those domains. So variety of applications. Then we are entering into the base knowledge representation and reasoning. So computational intelligence, then knowledge representation and reasoning. So we are entering into our core part for proposition logic, then first order logic. So proposition logic, then first order predicate logic. Then we are entering into the core part of unification. So first order logic and then unification. Then the session 2 for forward chaining, backward chaining, and resolution. Then which applies to variety of application, even for AWS cloud, which works based on this computational intelligence. Introduction on computational intelligence. So a small picture, a picture may work as 1,000 words. So there is a small pictorial representation. A camera can see the value. So machine that see the entire environment, which simply says computer vision. So computer understands the entire environment and applies its intelligence, and it can process, it can add something like that. So machines that see the value. So computational intelligence, just a small intro. So anyway, the entire FTP which depends on computational intelligence. So anyway, small intro. So computational intelligence is a theory, design, and application. So and a development of biological behavior. So entirely the computational intelligence. So entire machines which depends on computational intelligence. Normal PC or a cloud machine or a VM or any kind of applications which works on computational intelligence. So traditionally, there are three major pillars behind this CI. So there are three major pillars. The first one, which is called as neural network. So entire behavior of human behavior. So neural networks, it's a background technology of CI. Then fuzzy system or fuzzy logic. Then entire optimization techniques or evolutionary computation. So these are the three major pillars which began the computational intelligence technology. So AI versus CI. So artificial intelligence versus computational intelligence. Both are intelligence, but AI, which completely the intelligent behavior of a human being. So intelligent behavior of a human being which apply to a robot. So natural intelligence, something which will be called as natural intelligence in human beings. CI is a study of adaptive mechanism. It's adaptive mechanism applies to any kind of machines. So adaptive mechanism applied to any kind of machine. Some real world applications, human behavior, so speech recognition, handwriting recognition, optical character recognition, machine vision, NLP, even for big data analytics. These are some of the applications under the domain AI. In computational intelligence, all kind of applications, even for household application, even for a computer vision application, a medical diagnosis, banking or consumer electronics, any kind of optimization techniques, industrial application. So all kind of applications, all kind of real world application, the background core technology which will be called as CI. So computational technology is a background technology for all kind of applications, even for haptic technology, even for blockchain technology. So entire thing, CA is the background. So computational intelligence is a background technology for all kind of applications. So we are entering into the base. So knowledge-based agent. So computational intelligence, then directly you are entering into knowledge-based agent. As a name itself, a agent, it works based on knowledge. So agent, which works based on some knowledge base. So knowledge base is it's a database which comprising of entire facts. So based on the fact database, the agent can work. Agent in the sense a robot or a machine. So a machine can work based on the entire knowledge base. So an intelligent agent which needs to know a knowledge. An intelligent agent needs to know knowledge about the real world entity. So intelligent agent needs to know knowledge about the real world entity for taking decision and reasoning to act efficiently. So intelligent agent which works based on knowledge and make decision and reasoning to act efficient. So everything which depends on knowledge base. So entire machine, entire technology which operate based on this KB. KB is a knowledge base. So knowledge based agents are those agents who have capability of maintaining internal state of knowledge. So knowledge is a component which is placed inside a robo or any kind of agent. So in addition to that, a knowledge can automatically update that based on a real world applications. So it can update their knowledge too. Already a knowledge base is available. In addition to that, it can update. So the knowledge based agent, which comprising of two major parts. The first one which is named as knowledge base, second one which is called as inference system. So a agent which comprising of two core component, one which termed as knowledge base, the second component which is called as inference system. So this is a small pictorial representation. Always a picture may worth 1,000 words. So small pictorial representation, something called as architecture of knowledge based agent. So here there is an environment. So the entire environment, the input was captured from the environment. This is our agent. Agent is an inference engine. Agent is a combination of both knowledge base as well as inference engine. So this is our agent. So the input is sent to inference engine based on the knowledge, which verify the perception, that is the input. So which can verify, and then which can take a decision from knowledge base, and then which can act accordingly. That's fine. So taking an input from the environment and then inference engine which collect a decision from knowledge base. Based on the decision, the inference engine can act to the environment. That's called as agent. In addition to that, based on the current activity, the knowledge base is also updated. Based on the current activity, the knowledge base is also updated. So from the environment, the input was captured. So inference engine, based on the input, it can make a decision based on knowledge base. So knowledge base is an entire database which comprising of collection of facts, collection of truth statement. So based on the truth statement, it can make a decision how to act to the environment. So the inference engine can act accordingly. So this is a basic architecture of a knowledge based agent. This is a basic activity of architecture of a knowledge based agent. Okay. So a simple activity. So here input was captured from a CCTV camera. Input was captured from a CCTV camera. The entire city CCTV camera is monitored by a people. It's very tough. But a computation engine, a computation intelligent machine can analyze the entire mall or entire city CCTV camera, and then the agent can act like that, act based on human behavior. So it can find the findings. So something agent can work like that. So capture the environment. If someone's moving in and around the airport, immediately the intelligent machine can respond. Do you need any help, or do you need taxi or any other medical help, some other things? Someone moving here and there, then either their behavior is abnormal, they can inform to police, or sometimes they need a help, automatically the intelligent machine responded to them. This is based on computation intelligence. Currently, many of the airports, they are having these kind of facilities, automatic CCTV camera recognition. So it can automatically capture the behavior of the people, and then it can respond automatically. That's a great achievement of CA. So computer vision, it's also one of the sub technology behind computer intelligence. Actually, the computation intelligence is a core technology. The computer vision, even robotic technology, is a sub technology of something called as computation intelligence. So a machine that see the value, a robot can see the value. So a robot can capture the data or perceive the data from the environment, and then a robot can act based on the decision provided by the knowledge base. So a computer vision or a robotic technology, it purely depends on computation intelligence. So even for medical activities, so medical diagnosis or telemedicine, so entire thing which is depends on computation intelligence. So entire video processing or image processing are all kind of technology. The background core which depends on computational intelligence. So even makes computer to understand the image or video. So based on the computational intelligence, a machine can understand this picture holds 1, 2, 3, 3 cars. The photo was taken on something 31/7/2005. The photo having some more trees, greeny trees. Then photo having good lighting conditions, so it's morning. Then fresh flowers. Then having a house or hotel, something like that. So something even a sky was in a bright sky, something like that. So even something you can view the picture and say several things. Normally a word says a picture may worth 1,000 words. So the theme of this intelligence, you can extract those 1,000 words from that picture. So this is one of the excellent applications of CAT. So even for person identification or even for object detection, everything which depends on video and image processing, the background core which purely depends on CA. So even the environment can viewed by human eye, which can take an image, human brain can process it, and you can get the result. So the computer vision, it's also one of the technology begins here. So which can capture camera data and then image can take it. Your intelligent machine, this is for CI. Your intelligent machine makes a decision. Based on the decision, the robo or any other machine can act. So CA, it's a core technology behind all kind of recent technologies. It's a multidisciplinary approach. So the entire thing which is called as multidisciplinary approach. So a computer intelligence, an intelligent machine, AI, computer vision, machine vision, image processing, even for you, your imaging methodology, your biological vision, normally all those computer operation which purely depends on mathematics. So mathematics, ML or DL, machine learning or deep learning or augmentation technology, any kind of mobile computational technology, so signal processing technology. So all those technology, they CA as a core. So computational intelligence as a core for all kind of technology. So we are entering into the base. So a knowledge base agent, which depends on two core components. One which will be called as knowledge base. The second component which is named as inference engine. So a agent which comprising of two major components. The first component which is named as knowledge base. The second component which is named as inference engine. So now the first component, knowledge base. Knowledge base is the first component. So knowledge base. So it's a central component. Knowledge base is a central component of a knowledge based agent. So it's a core component, sometimes it's also called as KB. So normally knowledge base which comprising of collection of statements. So knowledge base is comprising of collection of collection of sentences. So normally it's not an English sentence, it's jargon. It's a word from our computer technology. So jargon. So these sentences are expressed in a language which is called as knowledge representation language. So here sentences are not an identical English sentence. These sentences are expressed in a language which is called as knowledge representation logic or knowledge representation language. That's called as proposition language or otherwise first order logic or first order representation. So there are numerous number of representation for this knowledge. So knowledge base, it's normally not a problem statement like English sentence. So which converted into some different form. That's called as knowledge representation language. So the knowledge base which stores the fact of entire world. So knowledge base is a database which stores the entire fact of the world. So currently there are numerous number of databases are available for structured, unstructured or semi-structured. Anyway, knowledge base which is something different. So which stores the entire fact in some knowledge representation format. Stores the fact in a knowledge representation format. So in addition to that, so knowledge base is a database which comprising of all kind of facts. The facts are represented in a proper format, the format which is called as knowledge representation language. So now, in addition to that, the knowledge base which is required for updating a knowledge for an agent to learn based on experience. Yeah, similar to a human being. So each and every day we are learning a new thing. So our knowledge was updated. Similar way, the agent also based on the environment, based on the real fact, based on agent's experience, based on the real world experience, the agent can also act like that. So based on this, the learning base which depends on knowledge base. So automatically, based on the real world experience, the agent can update a KB. So agent can update the KB. So knowledge base is a database. It's a central component which comprising of collection of jargon sentences. In addition to that, the sentences are represented in a knowledge representation format, which stores the fact about the entire world. This knowledge base, which required for updating their knowledge based on the real world experience. So this is a basic overview about a KB, knowledge base. So second component. So agent which comprising of two core component, one which is called as knowledge base, the second component which is called as inference system. So the second component which is named as inference system. So inference system, it means deriving new sentence from the old. So it can process your data and then make a decision. So based on a knowledge base. So inference system which deriving a new sentence from the old sentence which is stored in KB. So based on a knowledge base, it can derive a new sentence. So that's a theme of inference system. So inference system is a machine or it's a component which can derive a new sentence from the old sentence which is available in a KB based on user inputs. So inference system allows us to add a new sentence to a knowledge base too. So inference system which update knowledge base also. So a sentence is a proposition about the real world. Normally a sentence is a proposition about a real world. So inference system which applies collection of logical rules. So there are numerous number of logical rules. Normally a basic rule and or not. In addition to that, there are several kind of existing rules, De Morgan law, some other things. There are several kind of logical rules are available. So based on that, you can convert your knowledge base into new information. So the major theme of inference system, we generate a new fact. So new sentence. In addition to that, update a knowledge base. It can generate a new sentence or it can generate a new fact, and based on that, it can update KB2. In that inference system, which works based on two rules. One which is called as forward chaining algorithm. The second rule which is called as backward chaining algorithm. So inference system which works mainly in two major rules. The first rule which is called as forward chaining. The second rule which is called as backward chaining. So now the base was a agent which comprising of two core components. The first component which is called as knowledge base. The second component which is called as inference system. So knowledge base is a component which comprising of entire real world fact. The facts are represented in a different representation called as knowledge representation. The second component which is called as inference system. So entirely inference system which works on knowledge base, but the theme of inference system would choose to generate a new sentence or new fact based on the existing fact. So this is the theme of inference system. In that inference system, which comprising of two core algorithms, the first algorithm which is called as forward chaining algorithm, the second algorithm which is called as backward chaining algorithm. So as the name itself, it can process data in a forward manner, it can process data in a backward manner. So forward chaining and backward chaining, these are the core idea which is behind a knowledge based agent. Now the operations performed by a knowledge based agent. there are three major operations. The following three major operations which performed by a knowledge-based agent in order to show their intelligent behavior. So there are three operations. The first one, which is called as tell. Second one, which is named as ask. Third one, which is named as perform. The three major activity: tell, ask, and perform. As a name itself, tell, this operation tells the knowledge base what it perceives from the environment. So it can perceive the data from the environment. So tell is an event which tells what data, what information which captures from the environment. It can take a photo, or it can capture a voice. It can capture a video, something like that. So tell is a first operation which can tell a knowledge base what it perceives from the environment. So this operation tells the knowledge base what it perceives from the environment. The second component, which is called as ask. So this operation ask knowledge base, it can ask knowledge base what action it should perform. So it can ask a question. So based on this perceived data, what operation it can perform. So it can ask the agent. So the agent which can say some activity. So based on the agent response, it can perform the activity to the environment. So tell, which captures the data from the environment, it perceives the data from the environment. Ask, which can ask the knowledge base which action it should perform. So it can ask a question. Perform, it can perform the selected action. So agent tells some action which can perform move left or move right or go direct, something like that. So based on the agent response, the robot can act. So there are three major actions. First one, which is called as tell. Second one, which is called as ask. Third one, which is called as perform. Tell, the operation tells the knowledge base what it perceives from the environment. Ask, this operation asks the knowledge base what action it should perform. Perform, it can perform the activity in the real world environment. So these are the three major operations performed by a knowledge-based agent. Three major operations performed by a KBA, knowledge-based agent. So yes, the first activity tells, so what I perceive from the environment, what I capture from the environment based on camera. You can think about a CCTV camera, what it captures from the environment. Ask, based on the capture, based on the motion detection, what action I took take. So ask, based on the detected motion from the CCTV camera, what action I should take. I can inform to police, or I can alert to some other people, or I can send a SMS to something. So it can ask a question to the agent. The agent is an inference system. Then based on the agent response, agent says, so the activity was something abnormal, a person having a suitcase and placing suitcase on the railway station. So agent thinks that something, a suitcase having some abnormal thing. So immediately it tells to the police. So it can tells, the agent can respond, tells to the choose an action. The action was informed to police or send a SMS to some other people. So something like that. So it's a mechanism of an agent program. So three activity: tells, asks, and perform. Perform in the sense again tells, something like that, same. So tell, ask, and perform. So perceive a data, ask to the agent, and then perform the activity in the real world environment. This is a core architecture behind an agent program. So based on this activity, an agent program can work. Now we are entering into types of knowledge and then entering into some of the real world application, even for cloud, mobile cloud, or cyber security, or something called as blockchain or haptic technology, everything which depends on CI. So some recent applications, and then we are entering into proposition logic, first order logic, and then forward chaining, backward chaining. So you are entering into some real world applications. So types of knowledge. So types of knowledge. So this is for small basic overview, and then entering into some application, and we are entering into proposition logic, first order logic, and then forward chaining, backward chaining, resolution, unification. So types of knowledge. So first one, which is called the structural knowledge. So It's a relationship between object and a concept. So types of knowledge, which is a relationship between object and a concept. So even structural knowledge, a knowledge base, which record for mobile computing too. So because based on that, a web page or a application which can run on the mobile, even for tiny device. Then object fact, so declarative knowledge, heuristic knowledge, rule of thumb. Even knowledge about knowledge is very essential. Then procedural knowledge. So these are the several types of knowledges. Then normally this is what each and every technology can work, which sense the environment, then which can work based on knowledge, then a decision can made and act like that. So this is what a basic a computational intelligence or a knowledge based agent can work like that. So a CI, computational intelligence knowledge cycle. So even for artificial intelligence system or CI technology, which having this cycle. First one, perception, which can capture a data from the environment, then which can learn something from that data, which can update the knowledge too, then which can convert the data into knowledge representation and reasoning. Based on that, it can plan an activity and then execute that activity. So this is a cycle of AI or CA. So it is a cycle which is based on both AI and CA. So perceive the data from the environment and then learn something from that data and then convert the data into knowledge representation, and then you can make it into reasoning thing, and you can plan accordingly, and you can execute the entire things to the computational machine. So this is a basic activity which perform in a CI. So this is a cycle of knowledge cycle of computational intelligence. This is a knowledge cycle of computational intelligence. So captures the data and learn from the data and convert the data into knowledge representation. Then you can reasoning, you can plan accordingly and educate the thing and execute the thing from the environment. Educate or execute the thing to the environment. This is what a CI machine works. This is what the entire computational intelligence machine works. So some of the approaches to knowledge representation. So some of the basic approaches to this knowledge representation. The first and basic approach, which is called as symbol relational knowledge. The first and basic approach, which is called as symbol relational approach. So which is called as structured data. So symbol relational approach, which is a fact which represented in a relational database. So normal structured database representation. So even a height of a player, weight of a player, and total runs taken for the player. Something Tony, Sachin Tendulkar as well as Sagirka. So their height and weight was specified as well as their runs taken was specified, something like that. So, so this is a structured database which can represent the player height and weight and run. So this is also a kind of knowledge representation. So knowledge representation is not only a first order logic, not only a proposition representation, even a database, a structured database, which also called as KB. So this is called as symbol relational knowledge. So symbol relational representation, even for 3NF, third normal form. So which represented a knowledge base. So yes, simple table representation. The second one. Second thing, which is called as inheritable knowledge. So a knowledge base which inherits a data from a hierarchy, something, a hierarchical representation. So a data which represented in a hierarchical manner. So something, example. So Peter, instance of a cricket. So he's a cricket player. Then Ankit is a football player. So cricket as well as football. Both. Anyway, both the people are called as player. So both the people are adult male. So this is a simple hierarchical representation. So you can extract the data in a very easy manner. Similar way. Danny is a cricket player. Peter is a football player. So both are under 90. So this is a simple hierarchical representation. So if data was represented in a tree, if a data was represented in a tree, it's very easy to collect a fact from the data. So the first one, which is a simple database representation. The second one, which is called a simple hierarchical representation, that is called as inheritable form. The first one, a simple relational representation. Second one, inheritable representation in a hierarchical form. Now the third one, now the third base, which is in inferential knowledge. Here now we are entering into our computation intelligence form, that is inferential knowledge. So its approach to represent a knowledge in the form of formal logic. So inferential knowledge, its representation, a knowledge can represent in the form of formal logic. This approach which used to derive more facts. For example, Marcus is a man. Marcus is a man. So something which will be represented as a man of Marcus. Something you are easily represent, a man of Marcus. So a man is an object. So sorry. So yeah, something, a Marcus is a man. So you can easily represent an object. Then inference system. So you can easily represent it. Something, all men are moral. So something you can easily represent in the form of for all x. So for all x, something equal is not required. For all man of x, see tends to or implies, for all man of x implies moral of x. So you can specify something like that. So this kind of representation, this kind of simplest formal logic representation, which is called as inferential knowledge. So Marcus is a man. So you can represent in some different format. That logical format, which is called as inferential knowledge. So that logical format, which is called as inferential knowledge. So all men are moral. So for all x, man of x implies moral of x. So this is called as inferential knowledge. So this kind of representation, which is called as formal logic representation. So similar way, all dogs have tails. For all x, dogs of x implies has tails of x. All dogs have tails. For all x, dogs of x implies has a tail of x. So for all dogs have tails. So which represented something like this. So the greatest advantage of this inference rule, which can derive from more facts. So which can represent a truth statement representation. The major theme of this inference logic would choose to prove the genuineness, the guaranteed correctness. So there are many inference procedures are available. Proposition logic, first order logic, several kind of logics are available. So it's more popular in CL. So even for automated theorem proving, so automated mechanism, all kind of automated mechanism, which works based on this technology. So now, yeah, last one, a procedural knowledge base. So the first one, which is called a simple relational database representation, something called a table. Second one for inheritance representation, that's a tree representation. The third one, which is called as, so the third one, which is called as something inference logic. Here we are representing some knowledge representation logical form. Sorry. The fourth one, which is called as procedural knowledge representation. Here we are representing the knowledge in a if-then rule. The knowledge can represent it in a if-then rule. So something a fuzzy representation. You can represent it in a procedural methodology. So something a Lisp programming or Prolog language. So you can represent it in this form. So this is called as procedural knowledge. These are the four forms of knowledge representation. These are the four basic forms of knowledge representation. Then we are seeing real world application, and then we are entering into proposition logic. Some real world applications. So CI in technology. So this computational intelligence or this first order logic or proposition logic, which apply to all kind of technology. So the technology number one. So the first one. So all are more familiar about the technology which is called as cloud computing. So as a name itself, cloud computing, it's an internet based computing. So each and everything which works in a real world. So it can operate based on something called a software as a service, platform as a service, and infrastructure as a service. So how each and every technology works, even a single browser itself, you can create a VM, and then you can allocate a RAM, and then you can process an operating system, and then easily works even for infrastructure as a service, platform as a service, and software as a service. All those works on this kind of entire data center. So you can have a data center. In the top of that, the infrastructure as a service, platform as a service, and software as a service. How it works? So the entire things works based on computational intelligence. So how to allocate, how to create a VM, how to allocate required amount of RAM, required amount of processing capability based on the need. So if a data was overloaded, if something a request was increased, for example, in a research publishing day, so each and every student willing to view the result. So there is a huge request to that server. Automatically, intelligent machines make a decision. It's not abnormal activity. It's an expected activity, because if result came, automatically all the students are viewed the result. So automatically a load balancer can work, and then the VM can expand its capability. VM can expand its processor, RAM, and all other things. It can provide the service. So if one user request, it can provide a service. If 100 user request, it can scale up, and provide a service. If 1,000 and lakhs of user request, it can again scale up, and provide a service. So based on intelligence, number of requests was increased. Then intelligent machine which says the request was genuine, because that's a day of result publishing. So the result was genuine. So automatically it can scale up the machine and provide a service. If the result was abnormal, in that case, the intelligent machine automatically alert the mother cloud, to shut down its activity or to neglect that activity. So that's an intelligent machine. So based on their intelligence, a machine can act accordingly. If the day was result publishing, then automatically the request increases. So if needed, if the cloud, it's not possible for providing that service, that kind of huge service, in that situation, the cloud can automatically federate it to other cloud and can provide the service. So CI is a technology which perfectly supported for all kind of cloud computing component. Without CI, even for infrastructure as a service, platform as a service, and software as a service, which not works. Then the second one, even for AWS, all are more familiar about the buzzword which is called as AWS, Amazon Web Services, which comprising of all kind of component, all those things which works based on CI. The second one, mobile cloud computing. Currently, the cloud computing, which supported for all kind of tiny devices, mobile devices. So even mobile cloud computing, software, storage, operating system, data, resources, all apps, all security, all devices which stored on cloud, based on, please listen carefully, based on the user behavior, it can automatically allocate the needed software, needed app, needed resources, and provide a service. So entire behavior of the human being, which understands by the mobile device, the behavior analysis, which is a core part of CI. So mobile cloud computing, without CI, mobile cloud computing, which won't work. Then the third one, all are more familiar about these buzzwords. Something called as edge computing, fog computing, and cloud computing. Edge computing, so even cloud is a entire process. Then cloud can perform all those data. Nothing was happened. So even some of the operations which performed by edge devices, something called as sensors, even for ATM card, then for some other capturing sensor devices. So some basic process which processed by end devices, some process which processed by fog, some process which processed by cloud. So a CA is a tool, a computational intelligence is a tool which which make a decision that what kind of operation performed by edge devices, what kind of operation which performed by the fog devices, what kind of operation which performed by the cloud devices. So CA is a core component which make a decision that these operations are performed by edge devices. So these components are called as edge computing. So these are the operations which performed by middleware, that's called as fog computing. So these are the another set of operation which performed by cloud. So this is which is called as cloud computing. So some of the operation which performed by edge devices, some of the operation which performed by the middleware, some of the operation which performed by the cloud. So edge devices operation, everything which make a decision by CA. So computation intelligence is a core component for making all those decisions. So this is what computation intelligence work. So it's supported for cloud computing, CA is supported for mobile cloud computing, CA is supported for edge computing, fog computing, and cloud computing. Now, even for AWS IoT Edge, all are more familiar about this tool. This is for 300 days, which is free for 60 hours. So this tool entirely works based on CA. AWS IoT for the edge. So entirely the computational intelligence component, always the decision making algorithm. All are more familiar about decision making algorithm, something called as neural network, even for fuzzy system or for all kind of deep learning mechanism. So entire thing which is stored in a single machine, which is called as AWS. So AWS can comprising of thousands of services. So one of the service which is called as IoT for the edge. So which is an intelligent machine. So you are writing a procedure, whether it can transmit a data. For example, there are two kind of way. Whether if the data was very huge, the data was transmitted to the cloud, it takes more time. So it's very easy for moving computation to the edge. So you can move that program to the edge and process from the Arduino board or Raspberry Pi board, and then miniature the data and then taken to cloud. So this decision was made by AWS IoT for the edge. So you can write a program, data was very less, then data was transmitted to cloud and then processed. If data was very huge, then your computation task, that is your program, which is moved to your edge device, that is Raspberry Pi or something called as your Arduino device, and process and then return the data. So this is what AWS IoT works, which purely depends on CA algorithm, computation intelligence base. So AWS IoT Green Cross, it also works based on the same. AWS IoT Green Cross, which also works based on CI. Now, IoT as well as IoE. So Internet of Things. So each and every object which works are based on IoT. Currently, IoE is which is famous. Even people, process, data as well as things. So not only things, it can interconnect people, process, and data. So entire thing was integrated. So without a proper decision making. So decision making is not easy. So based on a real world fact, it can make a decision. So IoE, it's entirely the core behind IoE, which is named as CA. The core behind IoE technology, which purely depends on CA. Then even for AWS IoT. Now, the next foremost technology, very soon I'm entering into first order logic. Before that, this application, all those applications which depends on CA. CA is not a single topic. Entire thing which depends on CA. That's what I'm explaining everything. So virtual reality and augmented reality, all are more familiar about this technology. So augmented reality, so you can wear a camera and view that object, then you can view something 75% really you can view the object. You can augment something addition to that. For example, I can view the building via my eye, and I can say that building is a hotel. The hotel comprising of some more 100 or 1000 rooms, something. I can augment some additional things about that hotel. So 25% virtual, but 75% I can view real. But in virtual reality, my eye was closed. Then now I can virtually 75% virtual, only I can imagine 25% things. Augmented reality, 75% real thing and 25% things are virtual. But in virtual reality, only 25% are real. You can imagine 75% virtual. So these two technology actually extract 25% virtual thing is also tough. 75% virtual things also very, very tough. So you need an excellent computational intelligence. So you need an agent which comprising of excellent computation background, computational intelligence, then only this augmented reality and virtual reality works. So always all those technology, the background core which purely depends on an intelligent agent. The intelligent agent which depends on some of the background knowledge representation. So entire thing which represents a knowledge-based agent. Now, all are more familiar about this buzzword, Amazon Sumerian. Amazon Sumerian is one of the excellent tool which purely works for augmented reality and virtual reality. Currently, which is free for 300 hours. So after 300 hours, you can pay for that. So it's purely supported for augmented reality and virtual reality. The background which depends on neurons, so which is CI. Now, yeah, then we are entering into the core, the another part, the security. So even security, a blockchain cryptocurrency. So blockchain mechanism, which purely depends on a background technology, which is called as distributed ledger technology. So entire blockchain, which depends on distributed ledger technology. So entire thing which distributed to several other machines. So a computation can distribute it to all. You can think about a computation which is distributed to all. So each and every one which can perform that computation and then provide a secure environment. So blockchain gets properties of cryptography. So always all those cryptography concepts are captured, but the entire thing which distributed, how it distributed without intelligence, how a data will be distributed, how a register will be distributed without a intelligence, how a chain can maintain without intelligence, how an intelligent machine can work, how a chain hashing technology can work. So always a blockchain or any kind of distributed mechanism, the core component which is called as CI. So even a small example which is called as quantum ledger database, Amazon QLDB. So a quantum ledger database which can create a chain, a ledger database which is transparent and immutable. So anyway, it can create a chain, a QLDB which can create a chain. If the chain was, it's not possible. Even for breaking the chain, which is not possible. A miner can add each and every chain or each and every block which is added by the miner. So it can perform very huge activity. So without intelligence, these kind of operations was not possible. So entirely the QLDB activity, which purely depends on a knowledge representation. This cycle representation was purely knowledge representation. So security also achieved via this intelligence. Now, this is what thing. So a picture may worth 1,000 words. Here there is a huge tree. With the help of small saw, if you cut the tree, is it possible? So it will take 20 days or 30 days. Now, all those things which applied via a computation intelligence, via a single device, which is called as AWS. So all those activity, if you are interested in cloud, if you are interested in mobile cloud, if you are interested in blockchain, if you are interested in augmented reality or other blockchain or any other technology, even a single tool is enough. Single CI, that is computation intelligence tool, is enough for you. That tool called as AWS, which can offer all kind of services that's termed as EC2, that is computation as a service, RDS, that is database as a service, that's called as direct connect, that is route 53, then EBS, elastic bean stack for web services, S3 for storage service, even for huge load, if n number of user requesting a data, automatically which can balance via ELB, that is elastic load balancer. Then Route 53 for routing data from one web service to other. Then VPC, virtual private connection, which will establish a IP connectivity. In addition to that, which can provide elastic IP too. A single tool, AWS, which works, behind the single tool was CI. All are very familiar about that. A computation intelligence is a background of this AWS. So entire thing which works based on computational intelligence. So all those components which can work based on CI. So which can offer virtual reality, something augmented reality based on Sumerian, IoT based on edge, fog, cloud, then blockchain, QLDB. So all those services are available. All those services are currently freely available. So utilize it for your research too. Then even smaller piece of code, your computer is enough. We need no intelligence. A normal manual intelligence was enough. But if you are cutting a larger tree, the power cut size is needed. So you can go for AWS for your research as well as intelligent activity. Let's use cloud. So all are more familiar about this story, elephant and a blind man. So anyway, I will explain the story in 2 minutes. So once upon a time, there were 6 blind men are living in a village. One day, a villager said there was an elephant in a village. So even though 6 blind men, it's not possible for see the elephant. The blind men are willing to at least went there and touch and feel the elephant. The blind men are went there, and each and everyone touching different parts of the elephant. And one of them said, it's like a wall. First one said, it's like a wall. He touching the part of the elephant. He touching the part of the elephant. The second one said, the elephant is like a spear. He touching the tusk of the elephant. The third blind man said, it's like a rope. He touching the tail of the elephant. The fourth blind man, he touching the leg of the elephant and said, it's like a tree. The fifth blind man, he touching the ear of the elephant and said, it's like a fan. He touching the ear of the elephant and said, it's like a fan. The sixth blind man, he touching the trunk of the elephant and said, it's like a snake. Now the 6 blind men are argued with each other. One of them said it's like a fan, another one said it's like a spear, another one said it's like a snake, another one said it's like a tree, it's like a wall, it's like a rope. Actually, which one is correct? Which one is correct? The 6 blind men are touching different parts of the elephant and argued with each other. So CI. So CI is supported for mobile computing, haptic technology, blockchain, virtual reality and augmented reality, IoT and IoE, fog and edge computing. So CI is a technology which is supported for all. So 6 blind men are argued with each other, and at last the 6 things. It's like a tree, it's like a rope, it's like a wall, it's like a fan, it's like a spear, it's like a snake. So all the 6 components are combined together to form an elephant. Similar way, all those technology which combine together to form a computational intelligence agent. So computational intelligence agent is not a single component which supported the background was which depends on cloud, mobile cloud, haptic, fog, edge, IoT, IoE, virtual reality, augmented reality, blockchain, which depends on the entire things. So it's not a single core. The entire agent which can support it for all these technology, all the next generation technology, which purely depends on CI. So even the last one, business intelligence. All are more familiar about this business intelligence, BI. BI, the entire BI, which depends on CI. So even one fine day, I put on my Facebook status, the status was feeling sad. So automatically you are getting several set of responses, something called as feeling sad. So there are numerous number of responses, but the system respond, if feeling sad, I need kerchief. So immediately you can present the advertisement just for fun. For example, I put a Facebook or WhatsApp status. The status was raining. Immediately you send the umbrella advertisement or raincoat advertisement. So something which works. So umbrella raincoat advertisement. So even based on a small data, the data analytics engine, the computational engine, that is agent, agent can make a decision, a knowledge representation. So agent can make a decision. So if feeling sad, I need kerchief. If raining, I need umbrella or raincoats. So it can automatically make a decision. So it can decision making system which can make a decision, which can send a umbrella raincoat advertisement. So it can works like that. So immediately which can represent. So perceived data from the environment, the data was raining. So immediately the agent can make a decision. If raining, they need umbrella. So immediately they can send the advertisement from something Amazon or eBay or Flipkart. So many of the people place order. So that's a business intelligence. So the core behind BI, which is called as agent behavior. That's a computational intelligence. Now, a digital marketing. All are more familiar about this marketing website, Zomato, Swiggy, and Uber Eats. So one fine day, I'm willing to place an order of vada. Actually, the cost of vada was 10 rupees or 7 rupees. So I'm willing to order it in Zomato. So immediately they place advertisement in front of mine. The advertisement was donut. The cost of donut was 400 rupees. So immediately they place advertisement, and then something they place some favorite cricketer or some other things. Donut is a boost of my energy. So I think something, it's a bun material. Anyway, I place order based on this advertisement as well as based on some fun representation. I place order. So human behavior can easily analyze. I am willing to order a vada for 10 rupees, but easily the marketing advertisement was placed in front of mine, and I place order of 400 rupees. Tempted and place order of 400 rupees. That's called as real CI. That's a real decision making for attracting people, for digital marketing to people. So entire digital marketing technology, which works based on decision making, the entire decision making agent, which works based on CI. So at last, I'm entering into CI, and then we are entering into our core, first order logic. Okay, sorry. So haptic technology. So all are four familiar about haptic technology. The first one, I will place an order of dress material. So in Flipkart, so many of the order was failed. So till there is a huge crowd in Chennai Silks, RMKV, as well as Pothys. You think about the reason. So the reason was touch and feel. If you are entering into RMKV, Pothys, or Chennai Silks, you can touch and feel the dress material, and then you can easily place order. But if you are placing an order via online, so you won't touch and feel. So there is a new screen card was placed, a new screen card which is pasted in the top of your mobile. You can touch and feel the dress material. So that's the technology which is called as haptics. So touch and feel. So this texture exposure which is provided in the screen. So this intelligence, this texture intelligence which is provided by CI. So last one, smell technology and loss technology. So for example, I viewed a favorite chef program that's called Balkova. So immediately I want to taste it. Now there is a new technology. If you take a photo of a food item and then taste that in a mobile screen card, it can provide the taste and feel exposure. So taste and feel decision. So actually the screen card which is made up of octopus cell, but the taste and feel exposure which provided the intelligent decision maker, which takes a photo and make a decision, So which takes a photo and make a decision. The intelligent machine which makes a decision to provide the same taste and feel exposure. That's called as haptic technology. So for example, I'm entering into a hotel and take a food item of nearby person, take a photo, and then for example, I am entering into a hotel and take a photo of nearby food item and taste my screen card, which provide the taste and feel exposure. Actually, the intelligent behavior which made up of a screen card made up of octopus cell, which provide the taste, but the intelligent machines which provide the decision of the taste behavior. So these are the variety of applications which works for this CI. So all those technology which works based on this computational intelligence, the entire technology. So entire next generation technology, which purely depends on computational intelligence. So the application, all those applications which works on computational intelligence, even for smart newspaper, even for touch and feel smart newspaper, which works based on computational intelligence. Now we are entering into our core. The first point, we are entering into propositional logic. So starts from a small intro on computational intelligence. Then we are entering into knowledge-based agent. Knowledge-based agent, which comprising of two core components. The first one knowledge-based, the second component which is called as inference system. Then knowledge-based, which comprising of collection of fact and collection of real-world things. So all those facts are represented in a knowledge representation. So based on fact, intelligent inference system can act accordingly. The inference system, which comprising of three basic activity: tell, ask, and perform. Tell, which perceive the data. Ask, which asks the agent to make a decision. Perform, which can perform the activity. These are some of the basic overview of a computational intelligent machine. Then the second session, we will focus on propositional logic, first order logic, and then we are entering into forward chaining, backward chaining, resolution, and unification. So as a name itself, propositional logic is a very simplest form of statement representation. So we are representing it in a very simplest form. For example, it is Sunday. So today is Sunday, something like that. So it's a false proposition. So a sun rises from west. So false proposition. So 3 plus 3 something 7. So false proposition. So something. The proposition statement, the proposition logic, which represent whether either it's true or false. So proposition logic, it's a simple knowledge representation. It's in a mathematical form. It says whether it's a true or false, or otherwise it's the result is in a Boolean 0 or 1. So the proposition logic, it's a simplest knowledge representation. The result is in either true or false. So it's a simplest technique for knowledge representation, simplest mathematical form. So some of the basic proposition logic, it's a Boolean logic. The result was 0 and 1. So in the proposition logic, the symbolic representation, the either true or false, something it cannot be both. So the proposition can be either true or false, but not both. So some other rules. So in that proposition logic, there are two basic representation. The first one, which is called as atomic proposition. The second one, which is called as compound proposition. So in the proposition logic, the knowledge representation, there are two types of propositions. One which is called as atomic proposition. Second one which is called as compound proposition. As the name itself, atomic proposition, so which work in a single statement. Compound proposition, which combined in multiple statements, something like that. So proposition, which classified in two types. So example, first one, atomic proposition. So atomic proposition is a similar way, simple, always simple. Proposition is a simple logic. So simple proposition, it consists of single proposition symbol. The sentence must be either true or false. For example, 2 plus 2 is 4. It's atomic proposition. The statement is true fact. So the second one, the sun is cold. So also it's a proposition statement, a single statement, proposition single statement. The statement which says a false fact. So proposition statement. So proposition statement. So 2 plus 2 is 4. Then sun is cold. So it says a true statement, first one. Second statement is a false one. So it's a simple proposition. The name does atomic proposition. The second statement, which is called as compound proposition. So as the name itself, compound proposition. So the compound proposition are constructed by combining simple or atomic proposition. So combining two or more sentences or connective two or more logical sentences, which is called as compound proposition. Combining or connecting two or more sentences which form compound proposition. So it is raining today. It is raining today and the street is wet. So it is raining today, then automatically the street is wet. Then Ankit is a doctor and his clinic is in Mumbai. So the compound statement. So the two statements are connected based on a keyword called as and. So these kind of connecting statement, these kind of connecting two atomic proposition or simpler logic, which is called as compound proposition. So proposition logic, under that there are two categories. One which is called as atomic proposition, the second one which is called as compound proposition. Atomic proposition, which is a single statement. Compound proposition, which is a connecting two statements. Connecting two or more statements. Then normally there are several kind of logical connectives are available. Something called as and, then something. The Rohan is intelligent and hardworking. So P Rogan is intelligent and Q Rogan is hardworking. So something called as P conjunction Q, that is P and Q. So Ritika is doctor or engineer. So something P is Ritika is doctor, Q Ritika is engineer, not both. So P or Q, something called as disjunction, something which represents as disjunction. Then it is raining, then street is wet. So P implies Q. If raining, automatically street is wet. So I am breathing, I am live. So it's a bidirectional relationship. If live, automatically breathing. If breathing, automatically live. So something called as the bidirectional. So there are some basic logical connectives. The first one, which is called as negation, not. So automatically a compound statement which needs some logical connectives. The first one, which is called as negation. So either positive literal or negative literal. The second one, which is called as conjunction. A Rogan is intelligent and Rogan is hardworking. So P conjunction Q, that is P and Q. Then second one, disjunction. Something Ritika is doctor or engineer. So P Ritika is doctor, Q Ritika is engineer. Then P or Q. Then implication, P tends to Q. Then automatically, if it's raining, then street is wet. So P implies Q. P is raining, Q street is wet. So P implies Q. Then bidirectional. So I am breathing, then I am live. So P bidirectional Q. So both the direction was true. So these are the basic logical connectives in a computation intelligence, in a proposition statement, in a knowledge representation. So something, a connective symbol, first one which is called as and, it's called as conjunction. So A and B. The second one called as or, disjunction, A or B. Second one, third one, which is called as implies, implication, A implies B. So if A is true, automatically B is true. Bidirectional, if and only if. Bidirectional, which is called as if and only if. So A if and only if B. So both the directions are true. Not. It's a negation operation, not A or not B. So these are the propositional logic connectives. So these are the symbols which used for connecting statements. So these are the truth table. Something if true, not in the sense false, false in the sense true. Then conjunction and operation truth table. Then disjunction for or operation truth table. Then implication. So these are the basic truth tables. So limitations of this proposition logic. So any knowledge representation is concerned, there are some basic limitations. Any kind of any kind of basic limitation is concerned. So any logic is concerned, some basic limitations. So something called as for all, there exist. These are the not applicable in propositional logic. So at last, the rules of inference. So inference rules, anyway, as a name itself, create a new logic or new sentence from a old based on the evidence in a knowledge fact. So this is called as inference. Not for first order logic, we are entering into computational intelligence. So first order logic. So some humans are intelligent. Sachin likes cricket. So some other first order logic representation. So this is a proportional logic. First order logic is also a proportional logic, but you have some other additional features. So it's another way of knowledge representation in computational intelligence. So it's having some other connectives, some additional quantifier too. For all, there exists equality relation. These are some other additional connectives which are available in first order logic. So same atomic sentence. So something, Ravi and Ajay are brothers. So which will be represented as brothers of Ravi, Ajay. So Chinky is a cat, so cat of Chinky. So complex sentence, X is an integer. So in addition to that, in addition to proportional logic, in that first order logic, you are having some universal quantifier that's called as for all and extensional quantifier that's called as for some. So you are having additional quantifier named as universal quantifier and existential quantifier. So for all X, for each, for every. So this called as universal quantifier. So for example, all man drink coffee. So it will be represented as X1 drink coffee, X2 drinks coffee, X3 drinks milk, Xn drinks. So something you can represent in a separate way, but in an easy way you can represent for all X drinks coffee of X, coffee comma X, X comma coffee, something like that. So it's a representation. Similar way there exists or for some or at least one. So you can represent X1 is intelligent or X2 is intelligent. Anyone is intelligent. So there exists X, boys of X and intelligent of X, something. So universal X for all, existential quantifier there exists. So for all X and for all Y, which is similar to for all Y and for all X. Similar way, there exists X, there exists Y, which is similar to there exists Y. So these two property are true, but this is not true. For there exists Y for all Y there exists Y. So this is not a similar thing. So this is what some basic points to remember. The first order logic representation. So this is what very essential. All bats fly. All bats fly. So very easiest representation. For all X, bat of X implies fly of X. So for all bats fly, so automatically you can represent, and be a normal representation, fly the inference rule, then the object which is called as bat. So you can easily represent a inference logic here for all. So you can represent for all X, bat of X, which implies fly of X. So all bats fly. For all mans or for every man respects his parent. So for all X here, all X, man of X implies respects of X, the man X, then parent. So this is what for all representation. For all man, the man which represented by X respects X, comma is parent. So parent. So similar way, some boys play cricket. Some boys play cricket. So there exists boys of X. So some boys implies play cricket, comma X. For all boys play cricket. So for all X, boys of X play X, comma cricket. So here some boys play cricket. So in that situation, you can use extensional quantifier. That's called as there exists X. So there exists X, boys of X play X, comma cricket. There exists X, boys of X implies play cricket, comma X, comma cricket. Similar way, not all students, please, not all students like both mathematics and science. So here, not all students. So there is a negation symbol, there is not symbol, which added in front of for all. So not for all X, student of X likes X, comma mathematics and like X, comma science. So not all students like mathematics. So here the representation was student of X like x comma mathematics and like x comma science. So in front of there you are adding not. So not all students. Here only one student failed in mathematics. The last statement, only one student failed in mathematics. So there exists x. So one student of x failed x comma mathematics. Yes, this statement was true. One student failed in mathematics, but not all. So and all y not, the x is not equal to y, and student of y not failed in mathematics. So yes, please listen carefully. Only one student failed in mathematics. So there exists x, student of x, one student failed in mathematics. So failed x comma mathematics in a and condition. So for all y, other case, not x equal to y. So that student, the failed student was not taken here. So all other students. So for all y, it's another variable. It's not equal to x. So not x equal to y. Then that student not failed in mathematics. So only one student failed in mathematics. So all other students are represented in y. They are not failed in mathematics. So this is a basic representation of FOL. This is what basic representation of first order logic. So now a simplest one bit adder of first order logic representation. A very simple single bit adder of first order logic representation. Here the identifying the task, whether circuit can add properly, then a gate can work properly, then analyze the thing and then return the statement. This is called as knowledge representation. So here the proposition logic always works based on negation, conjunction, disjunction, implication, and bidirectional. So negation for not, conjunction for and, disjunction for or, implication for it tends to something, bidirectional for if and only if. So these are the basic syntax of propositional logic. So these are the very basic simple of propositional logic. So this logical connectivity, all those logic which works on some commutative law, associative law, and some implication and bidirectional De Morgan law. So all those digital transformation which works here. So all those logical activity, I won't enter here. So yeah, these are the basic of first order logic representation. So starts from knowledge representation and knowledge agent, and which comprising of variety of application. Then we are entering into first order logic representation. Now we are entering into two core algorithm of first order logic. So knowledge representation, first order logic, two core algorithms. One which is called as forward chaining. The second one which is named as backward chaining. So you are entering into base first one, forward chain. Yeah. So forward chaining mechanism. So as a simplest forward chaining algorithm, so P tends to Q, L and M tends to P. So P tends to Q, yes. L and M tends to P, okay. B and L tends to M, okay. B and L tends to M. So L tends to M, B tends to M, okay. A and P tends to L. So A and B tends to L. Then A is a separate component and B is a separate component. Then P tends to L. So these are the basic representation. A and P, sorry, this P. So A and P tends to L. Okay. A and P, A and B. Okay. So this is what representation. So this is a basic knowledge representation. Here, this knowledge base which represented in a graphical representation. This is what a knowledge base, forward chaining basic algorithm. Now starts from a base, a forward chaining example. Initially, which starts from a base. So A and B take an initial component. So A and B was taken. Second. So A and B. Now A and B, which implies L. A and B, which implies L. So L was taken. Now B and L, which implies M. B and L, which implies M. So which taken. Now M and L, which taken P. So which move to P. Now something P and L and M which move to P, then P which move to Q. So you are representing a simple forward chaining representation. A and B, L, B and L, M, L and M, P, P tends to Q. So you are representing. Now you are proving that again you are moving into a reverse direction and you are prove Q is true. Now the simplest example for forward chaining algorithm, normally forward chaining is also known as forward deduction or forward reasoning. Forward chaining which called as forward deduction or forward reasoning method, which using a inference engine. So which also using a inference engine, which triggers all those rules and which made a conclusion whether it's true or not, whether it's satisfied or not. A simplest example, the very simplest example, normally every book they are following this example. So as per the law, it is crime for American to sell weapons to hostile nation. So as per the US law, which says that American to sell weapons to hostile nation, their enemy nation, so which is called as crime. An enemy America has some missile. So the enemy of America, some other countries, they are having some missile, and all missiles were sold by some person named as Robert. So all missiles are sold by Robert, who is an American citizen. Robert is an American citizen. So based on this problem statement, you can prove that Robert is criminal. So always based on a human brain, you understand that Robert is an American citizen. So if an American citizen sells weapons to hostile nation, it's a crime. Then if automatically a person who made a crime, then it's called as criminal. So Robert is a criminal. So automatically human brain understands the same. So similar way, you convert the statement into first order logic and using forward chaining algorithm to prove Robert is criminal. So now step number 1, you can convert it into first order logic. So it is a crime for an American to sell weapon to hostile nation. So now let's say you can take 3 variables P, Q and R. American of P, weapon of Q, sells PQR, hostile of R. So American P, a person American, weapon Q and hostile R, hostile nation R. Then so American, weapon, hostile nation, they can sell to hostile nation. American sells weapons to hostile nation. So there is an and condition, which implies the people is a criminal of P. So that American which is called as criminal. So American of P and weapon of Q and sells P, Q, R to a hostile nation and hostile of R, which tends to criminal of P. So if an American sells weapons to a hostile nation, then he is called as criminal. So this is the basic representation. First sentence converted into first order logic. Then second one, a country A has some missiles. So owns A, T1. Then missile T1. So missile T1 owns A, T1. So sentence number 2 and 3 over. Then for all missiles were sold to country A by Robert. For all missiles sold to country A by Robert. So for all P, missiles of P, sorry, not question mark. This is for all. So here, for all P, missiles of P owns A, B and owns A, P, sells Robert P, A. So for all missiles which owns a country A, a person P, a missile P, which sells by a person Robert. Then missiles are weapon. Automatically all missiles are weapon. So missiles P tends to weapon of P. So enemy P, America is a hostile P. Okay, fine. Enemy A, America. So always A is a country which enemy to America. So at last Robert is an American. So American of Robert. So this is the entire problem statement which converted into FOL. The entire problem statement which converted into first order logic. here the whole problem statement which converted into first order logic. Now the representation. So forward chaining, initially you can write a base step. American Roberts, okay, separate one. Missile T1, okay. T1 is a missile. Owns A, comma T1. So country A which owns a missile T1. Enemy A, comma America. So the country A is the enemy of America. So all those separate what? The separate block was taken. So separate sentence was taken. Statement was taken. So this is step number 1. Now step number 2. From this 2 statement, you can take missile T1, which is weapon T1. Missile equal to weapon. So missile T1, which implies weapon T1. Missile T1 owns A, comma T1. If country A which owns missile, which means that which sell by Roberts. Country A which owns missile, then automatically based on statement 3, which says which sell by Roberts. So missile T1 owns a country A. If a country A which owns a missile, the missile was sold by Roberts. So it's a statement. Then if a country which is enemy of America, the country is a hostile nation. If a country which is an enemy of America, which is a hostile statement based on statement number 4. So you can from bottom to top. So forward chain, you can move into second stage. Now, so American Robert. So Robert is an American. Yeah, but he sells a weapon to a hostile nation. A person who sells a weapon to a hostile nation is called as criminal. So Robert is a criminal. So that's fine. So missile, okay, own hostile nation, forward, backward. Now criminal of person Robert. So Robert is an American. So automatically he says criminal of Robert. So Robert is a criminal. So this is called as forward chaining process. This is called as forward chaining process. The backward chaining, as the name itself, backward chaining, you can prove it in a reverse. Forward chaining, you can prove it in a forward direction. If you are proving in a reverse direction, which is called as backward chaining. Now backward chaining algorithm. So automatically the idea which works in a backward direction. So to prove that Q by a backward direction. Now starts from Q, then move to P, then move to LM, then you can move to last statement A and B. Then you can prove that the statement is true. That's called as backward chain. Now you are entering into same backward chaining algorithm. So which is also a reasoning method, which also helps to an inference engine. So always backward chaining algorithm, which helps to an inference engine. So which follows the basic rules to solve the first order logic problem to prove the statement is true or not. So similar statement. So if a person is American, he sells a weapon to a hostile nation, the person is a criminal. A country A which have some missiles, so owns of A, comma T1. So normally missile which represented in T1, so missile of T1. For all missile, dot question mark, sorry. For all P, that is missiles of P, which owns a country A, comma P. So if a missile which owns by a country, which sell by Robert to that country. So missiles of P, which tends to weapon of P. So always missile which called as weapon. So the country which is a enemy to America, any country which is enemy to America, that country is a hostile nation. Enemy A, comma America. So A is the country which is enemy to America. Robert is an American, so American Robert. So these 8 statements which extracted from our problem statement, these 8 statements are FOL. These 8 statements are extracted from our problem statement. These 8 statements are first order logic statement. Now the first line which starts from top. Here we are starts from top. So criminal Robert. So starts from top, the criminal Robert. Then we are moving to next. So Robert in a sense automatically a person. Robert is a person. So American Robert, okay. So weapon, he hold weapon, okay. Sells Robert, Q, R is a hostile nation. So now weapon is a missile. So missile T1. Then he sells a weapon. Then in sense he sells a missile. The missile which owns a country called as A. So now you are entering into hostile nation in the sense enemy of America. So you are entering from criminal Robert to American Robert, sells and hostile. Then you can move into backward direction. So the country is enemy to America. Then automatically you can say that the Robert is a criminal. So if you are moving from bottom to top, that's called as forward chaining process. If you are moving from top to bottom, that's called as backward chaining process. These are the two algorithms, forward chaining and backward chaining algorithm. Based on this algorithm, the core concept that's called as inference engine can work. A knowledge-based agent which works based on two components, one which is called as knowledge base, the second component which is called as inference engine. The inference engine, it works based on these two algorithms, forward chaining as well as backward chaining algorithm. Automatically, all those inference engine which works based on forward chaining as well as backward chaining algorithm. Now there are two another components which is called as unification as well as resolution. Now two another component which plays a vital role. These components which is called as unification as well as resolution. Yeah, last things. Resolution. So resolution which yields complete inference algorithm when coupled with any complete search algorithm. So resolution which makes use of inference rule, always which uses inference rules, which performs deductive inference, which uses proof by contradiction, please, which prove by contradiction. So always a resolution or forward chaining or backward chaining, anything can perform based on knowledge base. So anything can prove based on this knowledge base. So always knowledge base. So always all are well known about that. The one and only thing, the resolution which uses proof by contradiction. So knowledge base always which having collection of facts. So based on that a system can work. So unification which combines a proportional logic. So unification having a joint rule. For example, this first order logic representation. For all x knows John, x hates John, x. Jane knows John. For all y knows y, Leonard, and knows y, mother of y. Here for all x, again the same letter. So unify first line and all other things. John, x, unify the things Jane, x. Unify this line with this, it's true. Okay, x, y. This, but if a literal is both the literal are same, then the statement was failed. Don't unify the statement. This is a unification rule. The first statement which combined with all, unification. If the literals are same, then the statement was failed. Don't combine the statement. Literal was same, don't combine the statement. One second. Now the last example of resolution proof. Likes all kind of food. So which is represented by for all x, food of x likes John, x. So apples are food. So which is represented by food apple. So chicken is food. So food chicken. So anything anyone eats is not killed by his food. So we represent for all x, there exists y, eats of y, x, not killed by y, x, food of x. So Bill eats peanuts, that's still alive. So eats Bill, peanut, alive Bill. So Sue eats everything Bill eats. So for all x eats Bill, x eats else. So which is represented by a simple first order logic. Now you take a resolution proof. The statement was taken. Resolution proof. You can take from a negation, contradiction proof, likes John, peanuts. So always you can prove that from statement 3. You can cancel these two, then automatically which takes food of peanuts. Then from statement 4, you can cancel these two, then you can take eats of peanut as well as killed by. Now from statement 4, you can cancel these two and you can get kills of peanuts. From statement 8, cancel these two and you can get alive of bill. Not alive of bill, actually alive of bill. There is a contradiction, cancel both the thing, then you can enter into empty box which says that John like peanuts. The resolution proof which says that John like peanuts. So something, you can take a contradiction and cancel the things, you can prove the resolution proof. This is what a knowledge-based engine, an inference engine works based on resolution proof. This is what an inference engine can work based on resolution proof. The another example, this is another example, similar way which can cancel hate Marcus, Caesar, then cancel from Roman Marcus, then you can prove that Pompeian Marcus, then which loyal to Marcus, Caesar, then you can cancel these two, then you can cancel ruler of Caesar, then you can cancel this try assistant Marcus, Caesar, then person Caesars, then you can cancel this try associate, then you can cancel man Marcus, not man Marcus, then you can get a block. That's prove that resolution proof. Using this mechanism, yeah, inference engine can work. Using this mechanism, a inference engine can work. This is a basic overview. So I'm entering into base. So initially it starts with a small intro on computational intelligence and knowledge-based representation, proposition logic, first order logic, unification, forward chaining, backward chaining, and resolution. At last, we are entering into a small demo on AWS, which comprising of collection of tools, all those tools which EC2. It's a tool which works based on CI. So you are entering into small demo on AWS. One second. So before entering into session, yeah, how to catch the lion. How to catch the lion. So in my school days, each and every faculty came to the class and teaching several set of topics. So applying the concept for catching the lion, think about the situation. So where to apply? So always computational intelligence is an excellent concept, but where to apply the concept is very, very essential. So catching the lion is not easy, but applying the concept is very important. So you are studying several concepts, but where to apply the concept is very much important. So that's what this session would place. So Newton's method, for every action, there is an opposite reaction. First lion catches you, then you will catch the lion. Think about the situation. So Newton's method is an excellent method. I'm 100% agreed with the same. But applying the concept for catching the lion, think about the situation. So dear faculties, so it's our duty to where to apply this computational intelligence. So what are all the tools are available? So this is very essential. So if you are running a computational algorithm or intelligent algorithm or decision making algorithm in a normal PC, it won't work. It gives a result in 10 days or 20 days. So it's very too bad. So where to apply is very, very essential. Second one, Einstein's method for due to higher velocity, you can run in opposite direction of line run in a very, very fast manner. Line will run in opposite direction of you in a very, very rapid manner. At last, line will get tired. You will easily trap it. Think about your situation. So Einstein method is an excellent method, but applying the method for catching the line, think about the situation. So it's our duty to where to apply. It's very essential. A software engineer method, first catch the cat. If issues arise, update it, at last entering into line. Cat and line are equal. If software industry is concerned, first developing a program, second project, third entering into a product is fine. But cat and lion, it's not equal. So here it's not applied. So all of them saying there is a mouse in a computer lab. So cat also searching where is a bloody mouse. So where to search, where to apply is essential. So where to apply the concepts are very, very essential. So here there is a small demo on where to apply the intelligence. So if you are having a decision-making algorithm, there is excellent tools are available to apply that and you can get the best result. So not use a normal PC. That's what I play this demo for computation intelligence. So AWS having collection of tools, a collection of VM and computational engine which supported for your entire research. The excellent tool for AWS which named as EC2, Elastic Cloud 2, auto scaling Lambda EC2 container service. So I'm entering into small demo on AWS. The AWS which offers 600 hours free. So one and only hard thing was you can provide your credit card or debit card number. If you wrongly use any other component more than a required, it can send just a alert message as well as alert mail. You can say as normally software engineers do like that. Yeah. Anyway, normally we are all performing operations like that. And it asks any agreement, you can press next. So same way, it can send a message, you can say yes, then immediately it can collect the money from your credit card. So that's what carefully use that activity. But actually, it can offer the service in a free manner for 1 year. So initially, you can entering into the website https://aws.amazon.com. So this is a website which is like that. Initially, you can click on My Account, then click on AWS Management Console. Click on AWS Management Console. So which can ask your user ID as well as password. So you can create a new account which will ask your credit card number. It's 12 months free. It's completely 12 months free, but which having the paid service also. So you can carefully use that activity. So now I have my account, so I can enter my account ID and then press next. Each every account, for example, you are having your organization, you can get the ID for your organization. Inside that, you can give a username and password to all your faculties and students. So that's what the account ID as well as username password was differ. So here you are providing your account ID, username as well as password. After entering into that, which will provide the dashboard, which is called as AWS Management Console. In that AWS Management Console, here there is a text box. In that text box, which will offer find the services. Here you type Sumerian, which will offer Amazon Sumerian service. Here you can type S3, which can offer S3 service. So this is what, because Amazon comprising of collection of services. So you can easily find the services using the find menu. Now the step number 1, I will type EC2. So Elastic Cloud 2. So which will open the service Elastic Cloud 2. Immediately which will open the service Elastic Cloud 2. So it's a dashboard of EC2. So which will provide immediately, which will open a dashboard. Yeah. After login, you can find a service here immediately, which will open the service called as EC2 service, which will open a EC2 dashboard too. So here already I have an instance. So now I will launch a new OS. I will create a new computer. Inside that, I will create a decision maker engine to train my algorithms and then make a decision, and agent can work like that. So now AWS which open, and click on the button launch instance. Click on the button launch instance. Only 5 more steps, just 5 steps. That's what the algorithm ended. So intelligence machine works based on these 5 steps. So click on that button launch instance. So it can ask which OS you want to install. If you having a CD of Windows OS, then you can put a CD and then launch OS. But the free OS, very few free OS are available. Windows also free. So you can take a free tier eligible. You can verify here, free tier eligible. Based on that, you can choose the operating system for creating new intelligent machine. You can create an agent. The agent need operating system. So you can search operating system in that agent. So I will choose a Ubuntu server, which is also free tier eligible. So I will choose a Ubuntu server, 64-bit x86 machine. So I will choose that Ubuntu server. It's for my step number 1. Choose AMI, Amazon Machine Image. Image in the sense dump operating system. Image in the sense dump operating system. So I will choose a Ubuntu image. Now this is what free. 1 vCPU, then memory was 1 GB, then EBS only, low and moderate. This is only free tier. If you choose nano or small or medium, you can pay for that. So carefully you can choose a free tier eligible. So I will choose a free tier. So this is what, first I will select Ubuntu operating system. Second, I will choose a flavor called as micro flavor. Micro flavor, which comprising of 1 virtual CPU, 2.5 gigahertz processor, and memory was 1 GB RAM. This is only free. So not all services are free. So yeah, everyone is money minded. So always Amazon not offer free service. They actually attract customer to entering into their service. So they not provide all those services are free. So you can use a free tier for education purpose. So I will choose number of instances. So if you are having 10 faculties, if you choose 10, automatically 10 operating system was ready for performing decision making or distribution algorithm or working on a blockchain or miner. So it's very easy for create a miner too. So number of instance. So I will give 1. So it will ask how much hard disk space you need. So for a Linux operating system, it needs a 8 GB as a minimum. If Windows 30 GB as a minimum. So I will use minimum was 8 GB. If you increase hard disk space is not a problem of Amazon. So you can give 100 GB, it can allow. So you can give 8 GB. If needed, if you are creating 100 servers, if you name it, then it's very easy. First one is EC department server. Second one is ID department server. Third one is computer science department server. So it's very easy for classifying both. So in that situation, you can add a tag. So tag is used to identify a machine. So you can add a tag. Now it's not required for mine. So I have omit the same. So the Linux operating system normally accessed via secure shell. Otherwise, you can access any client, Putty Linux or some other client. So I will use SSH. So enabled SSH. Okay, fine. Anyway, that's what. Initially, I will choose operating system. Second, I will choose a flavor. Then next. Storage was 8 GB. Then now computational machine, that is intelligent agent was ready for performing your activity. Then I will click a button launch. Then the machine can ready. So press launch. It can ask a key pair. So you will create a key pair. I will create a key pair in the name of K7 AWS. So I will download the key pair. So key pair is saved in a file named as .pem. Key pair is saved in a file extension called as .pem. So you can save the key pair file. Now your instance was ready. View the instance. Now your instance was running. If needed, you can name your instance in Ubuntu. Something like that. Now it can automatically provide a public IP address. Free public IP address to your instance. Wherever needed, whenever needed, you can access your operating system. Even on travel, you can enter into this operating system and working on any kind of algorithms with the help of this public IP. Now I will create a client OS for client software for connecting to this operating system. So I will use a putty gen. So I will load my key, that is PEM file, then generate key, open my putty installer and provide my IP address as well as port number. Provide my IP address and port number. Then I will provide authentication key. Now it will connected with my operating system. So just a client software is enough to connected with AWS EC2. So it's very easy to connect with AWS. So wherever you can working on this environment, it's easy. Then you can install MATLAB or Python or any other tool. You can easily run your neural network or deep learning algorithms using a fast processing machine. So it can act as an intelligent VM. So inside that you can work any algorithm. It can automatically connected with virtual network too. It can offer virtual storage too. Same way, it's not only supported for Linux, same way for Windows instance. So step number one, for choose a VM, I will choose a Windows operating system. Same, I'm repeating again. A free tier Windows also eligible. So you can try it in your free time too. So choose Windows operating system. Then T2 micro, a flavor was T2 micro because T2 micro flavor was free. Then I will choose only one instance. So here, a hard disk space. If Linux 8 GB was minimum, if Windows operating system is concerned, which need a minimum of 30 GB storage space. If Windows operating system is concerned, which need 30 GB of storage space. So now I will choose a storage space as 30 GB. Then if needed, if you are having 6 departments, so each department having a separate server. So in that situation, for identifying a department server, you need to properly tag it. So a tag is very essential for identifying a machine. So now it's not required because I have only 2 servers for education purpose. So that's not required for mine. So here you will tag. If needed, you can add it. Now in Linux operating system is concerned, here you are choosing a protocol called as SSH, secure shell. If Windows operating system is concerned, here you are choosing RDP, remote desktop. So with the help of remote desktop, you will connect it to that machine. With the help of remote desktop, you have connected to the machine. So now click on launch button, choose the same keeper, and a Windows operating system was ready. Connect, get a password, and then connect, and then open that machine. It can open, ask the password, and then open the machine like that. So even for browser, which can open a Windows operating system, in that Windows operating system, you can work any kind of algorithm. It's a first base of AWS. This is what AWS can work. So with the help of AWS, you can launch any algorithm. Similar way, this AWS which offer something called as Sumerian for augmented reality, QLDB for blockchain, deep learning tools, IoT tools, edge computing tools, fog computing tools, cloud tools, in addition to the web services tool, database services tool, which can offer collection of tools. Even a single click, you can create a VM and working on that environment. So currently, which offer 12 months free service too. So it's very much useful for your student education purpose as well as your research purpose too. So this computational intelligence engine can work for NLP, speech recognition, and even for data analytics, make a hospital diagnosis system, telemedicine system. So all those systems, this system was support. So even Colab is an excellent tool for Python and deep learning. Anyway, this is also intelligent tool. Colab ID is also intelligent tool. But anyway, Amazon can offer these kind of services in a very easy manner. So the second service which called as storage, all of them using Google Drive. Anyway, Amazon which offer excellent service which is named as S3, a simple storage service. So similar way in a find service engine, you can type S3, which can offer a S3 service. For example, like a folder or like a drive, something my drive. So you can create a bucket and you can upload an image to that bucket. just create a bucket and upload a file or folder, anything to that bucket. So it can view the service to you. So even it's like a Google Drive. So Amazon which offer S3 service too. In addition to that, Amazon which offer EBS, Elastic Bean Stack. It's normal like a web server. I hope all are from computer background, so that's not a problem for Apache Tomcat. If you are deploying your project, Apache Tomcat project, something called as war file. JAR in the sense Java archive, war in the sense web archive, YAR in the sense enterprise archive. So here EBS which used to offer a service for web archive. If you are developing a project in PHP, personal homepage, or JSP, or servlet, or any other intelligent engine, so you can deploy it using these web services. So EBS is an excellent tool which choose to offer these kind of web services. You can develop a project and then host the same in EBS too, which can support a microkernel. EBS can support a microkernel. Currently, Docker, which is an excellent microkernel. Yeah, currently that's all are more familiar about a buzzword which is called as full stack development. So even for if you are having client side AngularJS or Ember.js or Node.js or something called as React app, native React app, if you are developing a project in this client, in your backend, you are using a language named as something servlet or Ruby on Rails or .NET or Spring Boot. So anyway, even for Flask or Django in Python. So you can combine the client side Ember.js and then top side, which is called as front, the back side, which is called as Spring Boot, and then database, which is called as Postgres. You can combine it in a microkernel, Docker, which helps more. Docker is an intelligent engine, so which can support it for all those industry. Currently, all the website they are using their microkernel with the help of Docker. So it's having these collection of languages. So for example, I will choose EFS for file system. It's not required now. I will entering into EBS. So I will choose EBS. I will create an environment. So normally, I hope everyone familiar about web technology as well as IP. So you need to create a Tomcat and then create a folder for web.inf and web.xml file and create everything and deploy your code is very tough. But here, just a single click, I can click web server environment. I will name it. I will create a PHP program and then click environments. The entire environment was automatically created. I will zip my PHP code and then upload it here immediately, which gives a unique URL immediately, which gives your unique URL for viewing your website in the entire WAL. So anywhere in the WAL, you can view the website via this EBS site. Like WordPress or some other things, it can support for all other things. Sorry, it can support for all languages. So you can deploy your code with a single zip file, automatically which deploy it in an environment, and then which creates a unique IP as well as unique URL. Wherever in the WAL, you can access this URL. This is what EBS can offer. So Amazon offers several intelligence tools. EBS is one of the intelligent tool automatically create based on your requirement. It automatically create a service based on your requirement. Now my last one. So the last one, the Amazon which offers Sumerian, augmented reality tools, several tools. Anyway, my last tool was a relational database. Even it offer NoSQL for unstructured database. It offer HBase, Hive, several tools. DynamoDB too. DynamoDB is an excellent tool. Anyway, I will explain RDS, which is a relational database, which can automatically resize if automatically load balance too. So single click, I will create a database. Even for Amazon, Aurora is a famous database. Now, anyway, I will create a database. For standard create, I will choose MySQL. I will provide a DB password as well as things. Please listen carefully. Please listen these things carefully. I will choose MySQL. I will choose user ID and password. Here, it will ask the cost was $240. So MySQL service was not free. MySQL service was not free. By wrongly, I will click create database. Immediately, it will take an amount from mine. So each and everything you can carefully verify. If you wrongly click on these things, now you can pay for $611. So even you can provide credit card first. So if you accept this thing, estimated monthly cost was this much amount. The initial cost was at least for $12. So once your database was created, it can take $12 from your account. So anyway, I wrongly create because first time I will choose the screenshots. So I will wrongly create and I will pay with $12. So anyway, sometimes negative activity also helps for participants to careful in their activity. So I will place this slide too. So anyway, free tier also available in Aurora and MariaDB and Postgres too. So you can choose a free database with a proper version. Postgres also, Postgres 13 free, but Postgres 14 was cost. So you can carefully choose a DB instance. And now my DB was DB macro. Please view here. This database was micro. This is free. This database was M5X large. So cost was $12. I will pay $12. Already paid. So that's not a problem. Okay. This is my account. So database was created. Once database was created, it provide a IP address and user ID and password. So I will connect user ID and password. So it's like a normal database. So you will launch with your query and create a DB and create a table and working with any queries, any triggers or cursors, everything. So AWS offers several kind of services. So you can working on that. This is another service which is called as AWS Sumerian. Like 3D Max, Maya, Film 4D, like that, you can create any augmented reality application. You can create any kind of game design. You can create any kind of augmented reality application or game design. You can use this excellent AWS Sumerian tool. This tool, which is, I think, 1 month free. This tool was only 1 month free. So if you are interested in gaming, a powered engine, and nowadays, many of them are interested in game design as well as virtual reality and augmented reality projects. So in that situation, for purchasing a laptop for amount of 2 lakhs or 2.5 lakhs, it's very costly. So in that case, you can create a free account for with the intelligent machine. So automatically AWS which offer this Sumerian. So many of them, if needed, you can use it for your research. AWS Sumerian. So this is a Sumerian tool. So here you can create any kind of component and color it and materialize it, and then you can deploy it with a demo. So automatically the pipped object is available. So you can fit your face, and then you can fit your eyes and nose, and you can make a color and dress color and move the object, leg and bones, and you can run and you can jump something. Even for Endran film made up of not Sumerian, actually Maya as well as from 4D. So actually Sumerian is also tool based something like the same. So in addition to that, AWS which offer this IoT tools too. So for edge and cloud computing intelligence, you can use this edge computing tool. This is the AWS IoT edge. This is automatically made a decision and then send a computation algorithm to the client side and then work like that. So this is what AWS IoT works. So these are the some base of computational intelligence engine. Anyway, I start from base and summarize in 2 minutes. So initially I start with what is computational intelligence. So always you can take an adaptive decision from any kind of environment applied to the inference engine. Normally, always all those knowledge representation and reasoning can work on knowledge agent. Knowledge agent, which comprising of two core components, one which will be called as knowledge base, second one which is called as inference system. Knowledge base, which having all those real facts. Inference system, based on that it make a decision. User can perceive the data, sorry, a machine can perceive the data, and then it can tells it to agent. Agent can ask its knowledge base for a decision. Based on the decision, it can perform an activity. So this is what a knowledge base as well as inference engine, that is agent, can work. For working agent, it can needs proposition logic, first order logic, forward chaining algorithm, backward chaining algorithm, and resolution and unification we supported for this knowledge intelligence. This what works for all kind of something called as all kind of machine can work based on all kind of machine or technology can work based on this CI. Even AWS is one of the excellent tool. They are offering numerous services which can work based on computational intelligence. So this is what a computational intelligence works. So anyway, just for you can learn more and more things for these 6 days. So I will explain some basic things. Anyway, at last I ended with a small story. So the story which named as Hare and Tortoise. I think it starts from computational intelligence, then entering into blockchain, then something called as augmented reality, virtual reality, then entering into first order logic, then forward chaining. Yeah, several concepts. At last, I ended with AWS demo too. So with a small story, Hare and Tortoise. So once upon a time, there was a race between Hare and Tortoise. The reason for the race was who runs faster. Tortoise said, I'm a fast runner. But Hare said, no, I'm a fast runner. So there was a race between Hare and Tortoise. Now race was started. I hope all are very much familiar about the story. So Hare, there is a huge distance between Hare and Tortoise. So Hare takes some rest under a tree. Tortoise will slowly move and reach the destination. Now the moral behind the story was slow and steady wins the race. Actually, in computer field, slow and steady wins the race is not possible. I will give a small example. In my UG Computer Science and Engineering, in my first semester, the subject which will be called as Fundamentals of Computing and Programming. I slowly studied that subject. I will complete the subject in my 8th sum with S grade, 100 mark. First sum fail, second sum fail, third sum fail, but 8th sum I will get 100 marks. Did you accept that slow and steady wins the race? So slow and steady, because technology was growing in a very rapid manner. Each and every day there is a new intelligent technology. There is a language called as A, B, C, D. Now in a language is said. So each and every day there are numerous number of languages. Numerous number of. Initially they are saying technology called as cloud. After that something called as edge, fork. So each and every day there is a new technology. So slow and steady wins the race, which is not applicable. So next day story continues. Next day, Hare think about its failure, then analyze the reason for failure. Because of its laziness, it lost the race. So next day, Hare met Tortoise again, then arranged for another race. Hare ran faster than Tortoise and reached the destination in a very, very fast duration. So fast and consistent, which will always beat slow and steady. So always if you are fast, then only it's possible for learning a new algorithm, new technology, or new environment. Then only it's possible. So always fast and consistent, then only it's possible for achieve more. Anyway, story continues. Now Tortoise will lose the race. So next day, Tortoise it's think about its failure, then analyze the reason for failure. So everything was possible. So now Tortoise choose a different strategy. In between source and destination, there is a river. Now Hare ran faster than Tortoise. In front of the river, Hare was stopped. Tortoise will slowly move and swam on the river and reach the destination. Now moral began the story. Choose your core competent area and then play on that battlefield. Then surely you will succeed. So you can work on the battlefield, then surely you will succeed. So Tortoise choose their battlefield, that is water. Then they can work on that environment, then Tortoise will succeed. So if you are interested in cricket, choose cricket as your core. If you are interested in augmented reality, apply your computational intelligence in augmented reality. If you are interested in something called as computer vision, apply your intelligence in computer vision. If you are interested in database, apply your intelligence in something called as unstructured database. So apply your core competent area, apply on that battlefield, then only you will succeed. Now hare and tortoise are good friends, then arrange for a final race. Hare and tortoise are good friends, then arrange for a final race. Now in the ground, hare will took over tortoise on the top and run faster. And the water, tortoise will took over hare on the top and swam faster. And in the ground, hare will took over tortoise on the top and run faster. Now both of them reach the destination in a very, very fast duration. The moral behind the story was teamwork. So one of them learning what is first order logic, another one learning what is resolution, another one learning what is something called as computational intelligence, another one learning how to apply this in Python or deep learning or Sumerian tool. So if we are working as a team, then only it's possible for achieving a new project or new research to the community. So teamwork is always plays a vital role. Anyway, I ended my session in Tamil. So முயலும் வெல்லும் ஆமையும் வெல்லும் முயலாமை ஒருபோதும் வெல்லாது. So if you work hard, then only it's possible for make a new tool or new research compound.